This shows that the school is growing. Right? If you don't want here, because I have to explain it here, I don't want to keep it out. Now, question can be, the question can be, here you are dividing by A. Where are you getting this A in the sum of the sequence? Here, why are we leaving this one as well divided by A? Because it will make no sense. If we divide by A here, it will be useless. That's why we are dividing by A in the last the sum, this one. This sum here is this one, is we are just having X here over A, which is our mean, is this one. Because this, when you look at the definition here is this one, right? So this is here, is this one. Have you seen that one? Now, here you can say, why are you dividing n by n? Because n by n, when you divide n by n, gives you what? 1 is the origin, right? We are to solve this. Where are you getting this n from? We are dividing everywhere by n, right? Here we are dividing by what? We are dividing by a here. Whatever is this n here, right? In other words, what is happening at the end here is again this is sum of x bar squared divided by n. If you look at this one, right? Yeah. Sum of x bar, this one, sum of x bar squared divided by what? A is this one. Divided by a, you know, is this one, right? Now, the formula we are looking at is sum of x bar squared divided by a. Again, I want to get where are we getting this n, another n. Because here we are looking at n divided by n. No, n divided by n is giving us what? 1, which is the origin. Here we are divided by n. So, if you look at this, when we are divided by n divided by n, it gives you the origin. If you are this. Alright, I think I will derive that from this one. I want.
So is that the one on your side line before?
This
one.
one.
I'm multiplying
This one.
that name, that's
Yes.
Oh.
It's this one. I think from there, the one I saying is you group like this and you divide this by 8, the one is this one. It's going to be like this, just this one. Right? Only just have only this format. So that this one is this one. And this is like this one. Now look at this one. This, if you look at this one, it's the same as the it's the same as 2x bar times x bar. Right? If you look at the it's square, right? It's the same as saying 2x bar, which is the same as 2x bar square minus 3x bar square here, and plus x bar square. This is the 2x bar square plus x bar square. This one is this one, right? From secondary school, you are subtracting, right? That's why you got 1 from here to 1, right? And then you get this one, right? And when you get this one, it will be sum of, you are getting this one, this gives you a 0 and this minus. So sum of x squared over a minus x bar, this one now is giving you this format. So this is a square, right? It's now where you are when you are squaring that one, so now you are getting that. Now you are coming up. Coming, I would have that for long. So this one, so what do you mean then? The most used formula that we are going to be using is this one. We are not using everything here. In the exam, I will not give the derive that, but I will just ask you. I will give you the formula. In the exam, I give formulas, and then what I want is you to apply. So let's apply this formula from the example I will give. So what is that will make it easier? Summation of x squared minus over a minus and next bar square. That's all. We have to cover this out in so there will be all of your x squared, then how many numbers are there, then find x bar squared, that's all it is there. Then come back, you go to an example, you see, we will use both methods and then see which one is correct. This one and that one, right? Divided primary.
I've done this delivery push for this delivery because the tendency for people to come up with makeup process and disturb them own applications. Advanced age for availability of room. I'm sure you've seen the notes. Yeah. For research, for statistics, I already shared a bit. What is the means for the assignment for research? Statistics. I said in practical, I will assess you based on the visitation that you're going to do, the observation that you're going to do in your schools. So that one is sorted. And today, I want to talk about the differential statistics. this one. Yeah. So this is what we want to talk about today. We want to talk about inferential statistics. Inferential statistics. So in our previous lessons, we've been talking about descriptive statistics as statistical tools that we use to analyze information of data that we collect. And then on descriptive statistics, we were able to establish that there are two types of descriptive statistics. And these are descriptives, actually measures of central tendency and measures of spread. So we were trying to understand what these measures of central tendency are. So we discovered that the mean, median, and mode are examples of measures of central tendency, isn't it? Apart from measures of central tendency, we also saw that we have measures of spread as a type of descriptive statistics. And the other measures of spread, we noted that there we have tools such as examples such as what? The range is an example of the measure of spread, variance, and standard deviation, ST. Okay? So these three, they fall under measures of spread. And the mean, modian, and the mean, they fall under measures of central tendency. And together, measures of central tendency and measures of spread are examples of descriptive statistics. So the past 4 weeks, that's what we've been doing. today I want us to begin a new chapter where we are now going to talk about the financial statistics. And the financial statistics are another group of statistics that are most used in analyzing data just like descriptive statistics. So let's define what are information statistics. So in simple terms, plate number 2 on the slide describes information statistics as statistics that help us to make inferences. Plate number 2. Remember this verse. We use information statistics to make inferences. See that statement? So inferential statistics are statistics that help us to make inferences or to make what? Conclusions from our data to more general conditions. These are statistics or statistical tools that help us to make conclusions, to arrive at a conclusion about our data. And not only arrive at a conclusion, but we are also able to conclude about more general conditions. We are able to generalize our findings to a bigger population, to a bigger group, beyond the group that we were studying, beyond our sample. It's a very simple meaning, definition, straightforward. Not even a sentence, not even a full sentence, just less than one sentence. Maybe we just one sentence. So information statistics are statistics that help us make inferences and conclusions from our data to more general conditions. More general conditions meaning we are able to generalize our findings beyond the people that we are studying to a wider group of people. So the people that we study are called sample. Okay? What is a sample? A sample is just a part of a larger group of people that we are interested to study. So, if you want to study all students at the University of Zimbabwe, there are many, so many. You cannot manage to each and every person to study him or her. Instead, you just select a few, and those few should be able to represent the larger group. So that group that you have selected is called a sample. And once you finish studying these people, the findings, the conclusions, you can apply in the rest of the students. So assuming you are trying to study mainly effectiveness of online education at the University of Zimbabwe for online students. It means you not study, you not give a questionnaire to each and every person. Instead, you just give a few. And whatever you find, for example, if you find fully online education or study, model of study at the University of Zimbabwe is effective, they will have a generalized online here. You can only do that using inferential statistics. That's why here we have an example. If you are trying to reach conclusions that extend beyond immediate data alone, for example, we use information statistics to try to infer from the sample data what the population might be, or make judgments of probability that the difference between the groups is a dependable one, one that might have happened by chance in this study. So that's what we are saying. If you want to make a conclusion beyond immediate data alone. Yesterday, I was in an argument with my brother, my older brother. So he was talking about something and he was making generalizations. All students from private universities are like this. Because him is at Mobile. So he's like, all students from private universities are like this. So I told him to say, I thought you were studying research methods where you where you were learning at Mobile. So you were studying research methods. I'm studying, I know research methods. So I said, okay. And you know that statement you have made is a biased statement because you don't have the evidence of what you're saying. No, I have evidence. I said, okay, give me the evidence. She said, one day I made such a person. So I said, okay, so you are generalizing that everyone who goes to a private university is like ABC, just because you are interacting with just one person. That's very small, too small sample size for you to make a conclusion. So you can't generalize this from one person, the views of one person, and you say, oh, people who are like this one, they think in this way. No. You would have said, this guy I did is from such a private institution, and he says ABC. Maybe people from there, they also think it. Maybe. For months of most by institution, and normally we say institution. But you can only do that if you have a representative sample, and then you also use differential statistics. Okay? So, statistics, in financial statistics, they use sample data to make decisions about a population. Do you know a population? When you say a population in the statistics, what does it mean? People. People. We also mean that. Need to be very specific.
Okay. When you're selecting sample, there's a whole number of people from those people. I mean, a group of people from where you were selected the sample population.
And I mean, this technology. You agree or disagree with what Christine said? Population. It's a group of people from where we are selected from. Okay, yeah. So, correct. A population is a group of people from where we are selected. And it's called target population. But it's more than just that. This population, where you have taken your sample, must have characteristics that are interestingly different from the rest. See? It means your answer was correct but incomplete. So you have to know Bangala research for the target population because Maramu even if it is longer targeting is big. Isn't it? There are others who are children, others are youths, others are young adults, others are older people. So say, do you want older people? That is going to be your target population. Wherever you are choosing, make sure you are able to say, I want people with these characteristics. That is going to be your population. For example, in a school, you can't just say, I'm studying impact of use of what do we call it? Projectors on teaching and learning in university. That was a beautiful research topic. Right? But when you say university, there are so many. So you have to define my university target. Maybe all public universities will be okay, that will be your education. Or private universities, that will be okay. And then if our private is over the end, only now the church, in a private life. So also define to say, my population is going to be all private universities that belong to religious institutions and churches. They will need, I don't know, in this of the private. So it means my population will come GMI, POU, okay? So population, you have to think in that way. You can mind this group, which is then what is that goal? When you have established your own kind of people, then come up with a sample. So sample should be either 10% or between 10% and 30% of the population. Let me repeat. Your sample should be between 10 and 10 to 30%. So if you've got 100 people as your population, if you are studying children in the school, you have two schools, and then when you're looking at school A, school B, what's the percentage? 100. You have, for example, population in 100. 10% of 100 is going to be what? 10 children or students, right? 30% of 100 is going to be how many children? 10. Am I right? So, if you say, well, my population is 100, these are children who are ignored in school A and in school B. From there, if you say I'm going to use a sample, then make sure it's not less than 10%. Ukapa interview position, ukapa questionnaire score position, make sure it's not less than 10. If you are going to be more generous, you can choose either between 10 and 30. if you have 300 as your target population, what's 25% of 300? If you have your row, sample of 25% of 300, do your calculation. How many people are you going to give questionnaire? How many people? Simple proportion, that's the mathematics. So 25 over 100 multiplied by 300. How would you? 300. Divided by 100%. And the answer multiplied by 300 times 35% of 375. In the ultimate questionnaire, no one is studied. Students of investment will arrive at 300. And then you say, I'm going to use 5%. Because the 5% is 10%. It means how many schools are going to approach 75? If you do that, the rest of them are there. You can conclude and say, that's information. Get it? You are using sample findings. But it is not as easy as this. Because you have to observe certain things. Like, for example, you have to use probability sampling. Probability sampling, it means you have to give chance of all these people. The students, you have to give them the chance to be selected. That's what probability sampling means. So you don't have to use purposive sampling, where you select, I'm going to select them and I'm going to extend. That is purposive sampling. But when you're using random sampling, it is not you who decides who is part of the sample. You have to use random sampling. So random sampling is an example of probability sampling. And probability sampling, we have several types because of different purposes. The common one is a simple random sampling. So simple random sampling is like a roller. I don't know if yes, you must be able to know what is order is, because these days, basic is not something wrong, isn't it? Basic. Basic something wrong. And the basic is order. Order. I don't remember so that way. Umajoka ni mambo ya something. So even the material simple as something. Because no sample ma beja ma wa okay? Then ma panga the great. Na mkuu Mungu ni kwa kama ni the same. So why is it ma kwa? It didn't defend itself in the fact. So I'm going to define it as Dura ni Mungu. Unsalilao. So that simple example, it uses what is called probability example, simple example. It's rotary by chance. But of course you increase your chances by putting more. Putting more your kind of base down family. But see man COVID, mambo yana number no yapo kila mfumo. Okay? So what you do if you have got 300 students here at the rest of the world, you just pick their names, give them numbers. What would you number number 2? Number 3? Number they are just email and basing or whatever. Number 4. And that's all number 4. You don't know what number thing number 9. Number 1, 2, back and 75. Go to the 5% of the what's the reality? They will not be part of the sum. Then you pick each paper, which is a 4, and 4. You want to know this is number 3. Number 3 generally choose a thing of social ways, and then you know instead of having the way. That is an option. Simple example. An example, basic sample. The other types of sampling you're going to take with such methods. Class. But this is not the same method. But I'm just trying to show you how in your educational research, ECD research, you are going to do some of the things in your research. Okay? Lastly, information statistics is based on assumptions that samples are randomly selected and analyzed. At the same time, information statistics is used where you want to test hypothesis or you want to investigate research questions. Very important. You use information statistics when you have a hypothesis. When you have come up with a hypothesis. Next week, I'm going to talk about hypothesis testing. The hypothesis is see my brother again, see my brother testing. But you have to know that research which has got a hypothesis uses information statistics in order to analyze the data. You can also use information statistics if you're going to research questions. In our research class, in America, task, you are aware of the task. Same one I there, I think. And I said you have to come up with a research topic, a problem statement, main objective, specific objectives, and specific research questions. Okay? So those research questions they help you to come with good information statistics rather than an analysis session. So when we are talking about information statistics, that's what exactly what we need. What are also the statistics or tools that can help us to make conclusions and also generalize our findings to the target population. If you do this, everyone is going to be happy with you. They are going to accept your research. They are not going to doubt it. Kwa qualitative research, you cannot generalize. And when you are using qualitative research, you don't bother to use probability sample. You don't use random. Okay? You don't use random sample. Some of us started the same thing. Sample. Because we use quantity. You want to use random sampling and you struggle with the same picture. If you use quantitative research, the first and second lesson I was talking about types of research. Another part of the research is described based on the research methods. And the research methods are qualitative, quantitative, and mixed. When you use quantitative, you use this. Or when you're using mixed method, you use this. But when you're using qualitative, you don't use this. So other people, they say, oh, let me run away from this calculation. Let me do qualitative. Then they come to analysis. They begin to struggle. Somebody called me and they said, I'm doing my master's degree. I have done data collection. I'm doing qualitative research, but I don't know what to do. I don't know how to analyze my findings. Please help me, doctor. Please help me. Not a doctor to help you. I said, okay, fine. If you insist, I will not do this for free. Okay, so quantitative research, you don't bother with this. It has its own method. But quantitative research or mixed methods research, you have to think about this thing. I wanted to explain something before I move on. We've already talked about population parameters. Maybe let me conclude by talking about what I have got. For you to connect very well. Yeah. So every research has got an assumption. Every research has got an assumption. Are you writing here? Are you writing that? Do you understand what you're writing? I just said this because I'll tell you again. So, like I said, information statistics is used to test the hypothesis. In other words, before you begin your research, you have to come up with that hypothesis. So that the information statistics should analyze that hypothesis by testing. So what is the hypothesis? The hypothesis is an assumption or a claim that you make about your population. The let me speak and write here. Because it's not there. A hypothesis is a claim or an assumption that you make about your population. That's the population management. Alright, I can finish the statement with that. So, a claim or an assumption that you make about the population. About the population for your research. So, every research, it always has an assumption. An assumption is like a suggestion or a proposition or a claim or a suspicion. That one would be a very good explanation. A suspicion. Since when those are the manga statement, you begin to suspect. That is a suspicion. So that suspicion is an assumption. You are assuming. You are not very sure. And you might be wrong. You might be accusing certain people who are not the actual, contributors. So that one is the hypothesis. What you have there is the hypothesis. So you do research so that you can prove whether what you are suspecting as happening is indeed real or not real. You are wrong. You want to prove that. That's what a hypothesis in research is all about. So, for example, if you see students pamoja na ile klasi kufunzika sawa majoma kwa mwenendo wa vitendo aweze, you will always say mwina hypothesis. Isn't it? Maybe this failure is because the students are not intelligent. Maybe the teacher is okay, they are not intelligent. Or they are intelligent, maybe the teacher is not. Happens to us so much. So, in any case where you have got a very good problem, you always have something that is suspected. So, in research, that's what we call a hypothesis. And there is a special way in which you present your hypothesis. So, in research, the hypothesis is presented in two ways. Or it is presented as a pair, a null hypothesis and an alternative hypothesis. They go together always. The number of them twins. Some of us are and normally you find them together. That's how a hypothesis in a research behaves. There are always two of them. There is a null hypothesis and an alternative hypothesis. Okay? So how does a null hypothesis look like? A null hypothesis looks like this. This is the symbol for This is now hypothesis, and this is the alternative hypothesis. Sometimes it's treated as the H1. So this is the symbol for a null hypothesis. Null is written as NU hypothesis, and HA is alternative. Hypothesis. This is the symbol. You can choose either using H1 or HA for alternative hypothesis. And this pair is one hypothesis. So it means that whatever now hypothesis need alternative hypothesis, don't only my hypothesis are we research, research, no. The one hypothesis only that comes in a pair. That's my bonus in biology, genetics. Okay? So, for example, like I gave you an example, you see that children are playing in grass a lot. You can hypothesize that as another hypothesis, you can hypothesize to say, or you can claim that teacher